Okay, so if you were to write a quiz, what are the basic concepts you remember from the marathon?
Differences between
physical and logical structure.
Mm-hmm.
Okay, anything else?
Beans.
Yeah, the beans is logical structure.
Yeah. So I've never used beans before, but I looked them up, and it's just basically, it's almost like an OSGI type of.
What's an OSGI thing?
Just a standardized sort of container with getters and setters. And
yeah, I mean, the way I look at it is that it's a way of deriving a structure from methods. You know, when we studied Pascal, at least when I studied Pascal, we spent a lot of time on records and nested records and how to go and extract, you know, a field from a parent record, and students have a lot of trouble, you know, with that stuff. And you go to object-oriented languages and suddenly that never happens, right? You're not supposed to go and access a public variable in an object. But that conceptually does happen. You are creating nested structures which are displayed in tree views. So that is why I go and introduce the word logical structure, and I tie it to a bean. Bean is essentially giving you a logical structure consisting of based on properties. So from the methods, you are extracting a logical structure. That's key. Bean is just one pattern for doing it. I can imagine an infinite number of patterns. And beans is giving you a fixed, it's doing records. Okay, so bean is a programmer-defined implementation of a record. Okay, and you can have multiple, and it's an active record that you change one field and another field can change also. So it's much more than a just record in C or C++ or Pascal. And then you may have your own implementation of an array, a sequence. It can be called array list, it can be called vector. We can imagine patterns for those. You can imagine your own stuff for tables. So the way I understand object-oriented languages, I go to Pascal and Mesa and I look at all the types they provided, which are called concrete types. They are not abstract types. And I say for each type, if I can define a pattern, then I can tie these languages to object-oriented languages. And I can do interesting things with them. And so when I teach 401, every one of them knows what a logical structure is by now, because that's what we're doing. And they're creating these nested structures. They're calling a method getter in one, and then calling a getter back in that method object returned. So that's your logical structure. Okay, that is what serialization today outside Java tends to be. If you look at the web, that's what they're doing. They're serializing based on method signatures, not based on variables. And that's how we go from C# to Java maybe, or at least C# to XML and Java to XML, and then maybe we can convert one XML to the other one. Okay. So anything else you guys remember from these slide texts? That's a very simple concept. That's a 401 concept.
IDL.
IDL. So how do you describe what's going on inside the representation? You could have an IDL. And why do we need IDL?
Multi-language.
Multi-language. What about other reasons?
Some situation you want a schema for something. Yeah.
Some standardization.
Yeah.
What about weakly typed languages?
Yeah.
Okay. IDL was first invented in Corba. There was a Toplas paper called IDL a long, long time ago. But it first gained popularity in a system called Corba. Anybody heard of Corba? Okay, so in the early 90s, late 80s, that was a very, it was all meant for inter-language thing.
Between C.
Well, so that was the theory. In practice, it was a distributed RPC mechanism for C. Because C is weakly typed. They said, describe your types using IDL, provide a mapping from C to IDL, and now we can have RPC for C. That was the practical reason for doing it. That in theory, it was multiple languages, but there was only C-based languages at that time. Okay, and then Java came along. It had RMI, and Corba just died a death. Okay, so today again, now that you have C# and Java and so forth, and they're all strongly typed, but we may want to convert from one to the other, so you might need an idea. Anything else you guys remember? Anything that you may remember for the sake of your assignment?
It's hard to describe, but just the overall structure of going to going through the whole process of visiting a generic node, and then when you handle that node, you can see that you need to go to a specific serializer for that class.
So the whole algorithm,
yeah.
including
and checking to see if you've seen it before so that you replace it with a reference to checking to see if it's non-transient.
Right. And the variations that algorithm may have based on what assumptions you're making.
Yeah.
Right? So do you remember that what assumptions could make things more efficient, more compact, less processing? So if we are going to different language, we might need an IDL to describe things, and we may have to send more information than if we were not going to another language.
Yeah, I think we assume that something is either a list or a theme.
Okay, that's the logical structure. So for logical structures, we need to assume what kind of logical structures we can have, and beans and lists were two very important logical structures. Do we talk about, in the assignment, I don't know if I give you a map also or not, if I talk about
I think in the assignment we talked about that.
Yeah. So maps are very important. And when you do these three things, you're in good shape. Okay. Anything else you guys want? I've got the main points here, but I just wanted to first see what you guys remember.
And there wasn't a specific term for it, but there was a fair amount of discussion of the whole, and it goes back to sort of touches the IDL thing that, you either have to sort of explicitly already know the data format or have it, some sort of a manifest or header that,
describes it.
Precedes and describes it, and that's sort of those trade-offs.
Right. So if I have, if I'm making, assumptions that, I know exactly, so that's the thing. How much do I know of what is going to be sent? Okay. If I'm making a remote procedure call, I know from the remote procedure call header at both sides what's coming. I know it's a increment method, and I know there's an integer, that's going to tell me how much to increment by, perhaps. Okay. Whereas if I'm serializing arbitrary objects, I have to provide more information to the other end. And including, does the other end have to have the class of the object that it's getting? And if it doesn't have a class of the object, can it do anything interesting with it? Do you guys remember that also? So you serialize your object into a byte stream. You send it to me. I don't even have the class of the object. Can I do anything interesting with it?
When you have the interface?
Well, even if I have the interface, I can't really look up the methods. I can't really, but let's assume I don't have the interface either.
You still can look at the methods and what they return.
I just don't have a class to go and even decompose the object into methods. The way you do that is to just get information with the class, because object is the pointer to the class. You always do object.getClass and class.get methods.
But so this is not an IDL?
Assume that, so if you have an IDL, I can go and look at the XML and do something with it. But supposing it's not ideal. Supposing I don't, you haven't described everything. Because IDL means you send the class with the object, essentially.
Yeah.
Actually IDL doesn't do that, sorry. IDL will never give you the method implementations.
Just give you the properties.
Just tell you what the method names are. It'll give you the interface. So what can I do with it? And I make a big deal of this because
Dynamically create a class.
so then you might as well get the class from the other guy. Again, that's, by the way, I mentioned that in my slides, that one of the distinguishing features of, or perhaps the most distinguishing features of Java is that you can pass class objects. You can serialize, and along with it, So I think I mentioned that in my slides. That when Java first came around, I met some inventor of Java at a conference, a guy called Waldo. He was giving a tutorial on Java RMI. I said, we've been doing RMI for a long time. Our remote methods, what's so special about Java's RMI? And he said, well, if you don't have a class of the object at the other end, we'll send the class along. Now, I don't know how quite to do that, but you can certainly pass a URL. And if you pass a URL, the other end can go and download a class object from that URL. That you can do. That I have done. But they don't just transparently send the class across along with the object. But that's the impression he had given me. Okay.
But isn't there a class object that you could just,
So you can serialize it. That's how applets come, right? Applets come.
Yeah. Those are usually a URL, because then you would know.
Yeah. So you can just serialize the class and send it across. So. Okay, so let's just go through these. So the main thing, this is implementation of serialization. This is not various interfaces for serialization, is the algorithm, right? And the algorithm in general, I don't know how well I captured it using this flowchart. But the idea is, that you're sending some object O. You are at some, you got, you know, your byte stream is at some position, and you have some data about what you visited already. Okay, let's say that's the algorithm, and that's, by the way, going to be the very tricky algorithm for you guys, you know. And you know, you go and check if it's already visited. Otherwise, you handle visited. Okay. Now you're going to do this for all non-transient components. How transient is defined can vary from system to system, right? And you send some header information about the object, which may be 0 bytes or might have more information than that. Then you take each component, you send some information about the component, right? And then you go and see whether the component is an atomic value or not. If it's atomic, you go and just send the value across. Otherwise, you have to go and recursively visit the component and come back to this point. Right? So what kind of information might you send here? You got an object O of some type T. You're passing an array list, you're passing a BMI spreadsheet, you're doing, you know, something. So let's assume something similar, simple. And you're sending an array list. What would you send?
Send the size of the array list, followed by each of the, like, and then the type of, and then one of each of the type.
Okay, so what if I'm passing a vector? Same thing?
Yeah, you could just have a.
So how does the other end know whether to create a vector or array list?
You can just make it a more general type. Because it doesn't have to, I mean, since they share the same interface.
So you can convert an array into a vector,
Yeah.
right? But what if you're doing in Java? You can't, in Java serialization, you can't do that. And what how do we, you know, what if you're sending, rather than array list, you're sending a map?
You want to just send like name value pairs.
Okay, but how do I know how to interpret that?
So in order to, you know, like I said, you have to send an identifier of the object type followed by
Okay,
the link.
so that's my header. I have to first tell the other end, you know, what schema to use. And that schema might just be the name of a type. Right? So that's this header information. Now, what about component header? So I have an array list again. You said you send the size
Yeah.
and each value. Do I have to send any header information with each value?
Index?
Sorry?
Index?
Not necessarily.
But index, they'll be in order, right?
Unless you have like a sparse list.
No, let's assume just, for now, let's assume just an array list, you know, just, it's just not, yeah. Yeah, if it is, otherwise, okay, so if it's a table, I might have to send,
Or just like a sparse matrix or something that
Yeah.
has.
okay, so we might have to send that. If it's a bean, we may have to send a property name, right?
Yeah.
And anything else we might have to send? Yeah, so we have to send some component information. And then there'll be some header information sent for that also.
So what's the difference between those two header?
So I have an array list. I have to send information about array list that has inside it a string and another string, let's say. So I have to send the information that I have to first say that this is an array list. Then for each value, I have to go and say, in the case of array list, I don't have to say index 1 or 2. That's, you know, that's implied. But
And
in
if
the
it
case
was, say, object, then you would have to put the type with all of the values,
for all the values,
unless you can guarantee that they're all the same.
unless you can guarantee they're all the same, in which case we can do some compression.
But it seems like that would be the same thing as the header, because this is like a recursive thing, right?
Right. So in case of array list, the header information will be 0. The component header will be 0. But in the case of of a bean, I'll have to send the property name along also. Or if it's an object with an instance variable, I have to send the instance variable name.
And with when you're handling, if it's visited, would you just make a reference backward in the bytes, like where you
Backward.
wrote that first?
Yeah.
Okay.
And that's going to be the fun part. You know, it's going to be really fun when it works. I mean, it's just going to be a joy. Really. This is very tricky. I mean, I know that the original implementation of RMI used to just, from what I remember, would just, you send it to cycle and it just won't serialize.
So would you have a special thing to signify that this is a reference before you would send the pointer?
Do you have to go and somehow encode that? Right. Okay. So you guys get the base. So this is this is the real challenge you're going to have. And this is the algorithm. Okay. So now we're going to look at exactly how we can simplify this, how we can make it more efficient based on various assumptions. So do we always need to send the type ID? So when do we not have to send the type ID?
If it's assumed.
Assume. So can you think of a practical situation where the other end just knows what type to expect?
I call the method, I know the return one.
Ex-
Yeah, do the,
Or called, I know the arguments.
do the externalization.
Marshalling?
Yeah, I mean, yeah, on the other end, it has the class and the methods.
It has it. In both cases, we assume it has it, but the other end knows that the next thing is going to be of this type. Somehow it knows. And that can be done because, there are, so, we can imagine having, a byte stream or an integer stream. You can imagine opening an integer stream or a string stream, in which case we already know that we're expecting only strings. Okay, as long as we don't have polymorphism. Polymorphism creates problems. Okay, as long as these types don't change, things are much simpler. Okay, so that's what the original implementations of serialization did exactly. They used to just send primitive values. It was done in the context of method calls, and you just knew what the next value was. You never sent the type information. Okay. So type needed when other. Okay, then the question was, so what are you guys going to do? Are you going to serialize into strings or are you going to serialize into binary streams? And what are the pros and cons?
I mean, if it's string, then you can assume readable.
You can?
If it's string, then assume readable.
So you can debug. I really recommend you do strings. It's going to be slow. Okay, and you can convert to binary afterwards. You just have to take the primitive values and do it one way or the other. Okay, and it can be done for multiple languages that way. Easily, we don't have to. Well, you can do that with the other things too, but it can be done. It can be sent over the web. Let's put it this way. And a lot of these RPC mechanisms today assume that they're going through the web server. Okay. In fact, I think I mentioned. Way back, somebody had an idea, or I had an idea, I think. I don't know whether I read this or had this on my own. I wanted RPC to go through email. Yeah. And, today you almost have that. So So what are components? Now we get into that one level of detail. Okay, are they physical structure, which is instance variables, or are they logical structure, which means they're based on patterns, bean pattern or some other pattern. Okay, and what are the pros and cons of physical structure versus logical structure?
Physical structure is more efficient.
It's more efficient because.
It's less information.
Why do you say so?
Because it's just the data instead of all the structure and the data.
No, but if I have an object O with variables v1 and v2, or have an object O with properties p1 and p2, what's the difference? In one case I have to send. I can't just take the memory snapshot and send it, right? I still have to go and send the name of the variable or the property.
But you could also just have your fields in order and then.
You could have the properties in order also. You can alphabetize them.
That's true.
In fact, can you have two variables of the same name in an object?
Yeah.
Can you have two properties of the same name in an object?
No.
Because you can have only one getter. So, you can assume the alphabet, so.
But one would, I'm assuming you're referring to like your super having the same variable name. But then it would still be technically super dot name and this dot name.
So I have to send the name.
They're still in different namespaces.
So you're saying we can order the variables based on that
Yeah.
somehow? We can't use alphabetical order then, right? But we have to just use some other
You could just like say super variables order.
come before in that order. Yeah. Okay.
And you only have your immediate supers variables, right? Or do you like if they
You have all the variables names.
But like what? So like let's say I have this. My grandparent defined A, and then my parent defined A, and then I defined A. Is it super dot super to get to my grandparents' A?
You can't get to, if the variables are declared private, you can't even get to them. Okay.
No.
I don't think can you say super dot A for a variable? I suppose you can.
Yeah.
I hate the idea of having multiple variables.
Yeah. That's what I thought you were getting at. Is that if I'm overriding, but I'm not really overriding my parents' variable.
See, I don't override, right? So I have to go and send all the A's to the other end.
But yeah, but I mean, you're not technically overriding because it's. But I guess you're not technically. Yeah.
Because what may happen is that at the other end, I may call a method in the grandparent that goes and refers to A.
And then it would be that local.
It'll be that local A. I've got check style and there's an option in Java that it'll tell you if you're overriding a method, if you are redefining a variable. Please use that. It's just such a bad design, I believe, on Java's point of view. Smalltalk didn't allow that. Okay. So, which is more efficient? Logical structure, same thing can be done. You can alphabetize things and so forth. Okay. So, which is what are the pros and cons now? Efficiency-wise. Think array lists and think no custom serializer. Which is more efficient, logical structure or physical structure?
Logic. We send less data.
You send just as many data items as have been created rather than the big array that you've allocated. In fact, whenever you customize the serialization of arrays, you're really trying to send the logical structure. And which is more general? General means you can serialize any object. The more than
Both as general, it seems like. They're both infinitely general.
Well, yes, they both can have infinite number of objects they can handle, but some infinities are bigger than other infinities.
Okay.
But you need logical structure to be able to become language independent. So that's something more general.
We're
Okay, in that way,
not
in that
dealing
way.
with anything that's uncountable, so I think if you could.
What is the so So generality in that dimension, you're right. But generality in terms of number of types you can send, or the exact set of types you can send, is one type, one set, one is proper superset of the other.
Logical is a subset of physical.
Because
Because you have lots of different representations in the same like interface.
okay, so that's true, that you can have multiple implementations, and
Why can you not encapsulate all those ideas in some kind of logical structure?
yeah, you can have an interface, and you can so that's good that you can target one guy. You can take one guy and target it to a class of another. That's good. So that's another dimension. But what about the number of objects I can just send across the wire? The set of objects. Can I take any object and send it, assuming it's got non-transient variables? Can I send any object across for, in the case of physical structure? Yeah, I just use. For logical structure, what do I have to do? I have to say, is it a bean? Is it a list? Is it a map? And if it's none of these three things, what do I do?
Give an error.
So you have to come up with some patterns. And anything that doesn't follow the set of patterns that you have defined cannot be sent.
How do you use something if you don't have any idea what it is?
No, you have an idea. You know it's a stack. You know it's a queue. It just hasn't followed a certain pattern. The programmer knows what it is. You just come up with some sparse matrix representation or some type that nobody's ever thought about.
Yeah.
You've come up with a new interface and we have not defined a pattern for it. Every object has instance variables. Not every object need follow one of the three. A finite number of patterns can be supported because you have to anticipate them. Because you have to interpret the methods in some way. And what if you have defined no interpretation for some class that you've defined?
I mean, it seems like you would just come up with a logical representation.
So then okay, so then you come up with a pattern for that. But a system comes first, and so system is defined, it's cast in stone at some point. At some point it's implemented and given to you.
Okay.
After that, you may come up with something that hasn't anticipated. In practice, it may not. I'm not saying it's going to be a problem.
Mm-hmm.
In theory, and in theory too, in some sense, I've gone very deep into pattern-based things, and I have to keep changing my patterns all the time, and I know there are certain things that I can't do. I mean, there's probably good, interesting types that I haven't defined a nice pattern for. But yeah, I can go and assume that every interface that's ever created, I create a new pattern for it, and then it reduces to a pattern-based thing. Because I have to go and the pattern will tell me how to take the object and extract its components. So there has to be some way to do that.
Yeah.
What are its components? Some mapping I have to get. And what's a component is in the eye of the beholder.
Beam introspection is much quicker than reflection.
No. Beam introspection uses reflection.
It uses reflection.
Well, at least conceptually it does. It might short circuit a few things. So I've given you the introspection utilities, by the way, for both lists and beams and maps, I think. Okay? So comparison, physical structures, memory representation, logical structures, interface plus pattern. Okay, so you take the methods, you go and use a pattern, and actually a student of mine did a thesis on patterns, and he defined an extensible structure to go and take an interface and build your own pattern definitions for it. So when I said it's cast in stone, it doesn't have to be cast in stone. You can inject some code into it. But if you're not willing to do that, then you have an issue. Okay. So not all objects follow bean pattern. I've defined a list pattern, but that's my definition. Nobody else in the world has defined it. So what most of these logical structure serializers say, you can have a bean, or you can have an array list, or you can have a vector, and that's it. And you can have a hash map and a map, and that's it. If you have your own implementation of a map, you have your own implementation of a that is not following the map interface. In fact, they don't do interface-based things anyway, or they might be doing it. I think they might do interface-based. But if you have your own interface that is, has only some of the methods of list, they can't handle it. Okay, so that's what happens in practice. And then they tell you, well, just use our customization facilities. That's what they say.
So bean is just an object that follows a certain set of conventions. So basically you're saying a bunch of objects, a way to list them,
You
and a
also
way
say
to...
any object as a bean object with a zero property.
Yeah, you can do that. But then you're not getting the components you want to. I think of bean as being like a logic, like Prolog-like logic applied to methods. Okay? Because what does Prolog do? Prolog says we'll take some rules and extract information from it. So if you have, get p returning a value of type t, and then you've got set p taking an argument of type t, and these two t's unify to the same value, and these two p's unify to the same values, where unification means that you can take a variable and assign it consistent values in both cases. Then you've got a property p of type t. So it's not just conventions. It's not just calling it get. You're extracting information from it. You're going and saying, I'll derive from these methods some components, names and component types. Some way to get the components out, and these are typed components. Okay, but like I said, practice bean list hash map patterns should suffice, and they kind of do. Okay.
And if we have a read only or a set only value, then we wouldn't have to pass that property. If it was just set p and it was going to get p, then we can just sort of ignore that as a property.
Yeah. You can't send it across. In fact, and if it's got only a getter and no setter, then you can't send it across either. You can send it across, but you can't do anything with it.
Well, so but then, let's say in your class, in your constructor, you initialize that
You initialized it,
property.
yes.
And now you want to send that property, but you can't set it. You can't use reflection to get around the.
But I think if you define a bean without a setter, that means you want this property to be read-only.
Yeah, no, but so let's say when I create my object, I give this property that from now on is going to be read-only.
Yeah.
So
you can
this object's already created
initialize
now.
this property, but you
Yeah, so
cannot-
then if I send it across, do I have to reconstruct the entire object?
Okay.
Or
So that has to do with the transient stuff we were talking about. It's very related matter. Okay, and remember that there is some way we need to initialize transient values at the other end. Okay, and how do we do it? In Java, that means you have to define your custom serializer. That whenever it goes in, reads the object, it goes and executes this code. Okay, and in the case of logical structure, and in your implementation, you'll have to define a method called init serialized object. That will have to derive the values. Okay, these values better be derivable from the values that are sent. If that is not the case, which in your example can happen, then you're in trouble. In fact, if you don't, I think you have to assume that these objects have constructors with no parameters.
Yeah, that's a weak thing. That it has to have a default. One of the constructors has to take no arguments.
Is that what bean requires?
Yeah.
Really?
Yeah.
even if it's a private.
It's just anything to reconsider. It's like one of the core aspects of being a bean is that you have to have an empty constructor, at least one.
Okay.
But then if you don't have a set method, then
Yeah. What I suggest in practice is that you should have an init method. That's what
You
small
also
talk.
have a private set method.
If it's a private set method, it's
You might as well just separate it.
it's not. It's basically.
I think a private set method can be called with a reflection.
Yes.
But, yeah.
That's true. Oh, but you can. Yes, that is true. That is true. So maybe that is the key. But I think what you should really have is an init method. And I really think, with factories, init methods make sense. Where init methods are just like set methods. They're expected to be called only once by convention.
But then it's like, if this init method would be called when you constructed the object, right?
Yeah.
So then if you've already constructed the object, it's gone through some state changes. And now I'm sending it. I wouldn't want to call that init method again.
Yeah, that's right. But I'll call the init method at the other end. I'll do the get here. I'll do the get at one machine, send the value across, go to the other end and say, does it have a set method? If so, I'll call the setter with this value. Otherwise, I'll see, does it have an init method? I'll call the init method. And that's called only once at the other end.
But still, you would have to pass in, like, this init method could have all of the necessary arguments to...
Yeah, no, I think you'll need to have an init for each.
Init for each object, each type.
It gets tricky. So it gets tricky.
I think you can define a default, a default method in some interface, some super interface, and then your implementing interface will extend this interface, and then you put your initialization logic in that method, so that you can't just the other end knows when I receive an object from the other end, then I need to call this method to initialize every property in the bin.
So but it would just be one method, or a method for each of the arguments that you would get from the
If it is a method for each argument, I think it's nothing different from
No, that is more organized, right? A method for each property is something you can reason about. Otherwise, you have to figure out which order to put these values in. It becomes very tricky. And
is there a way that you could win a method, you could get just a little list of your arguments and then pass each one to an init method, and then because of
so you're saying
overloading, you could have a different init method
no.
for
What are
each
you
of the
saying?
arguments.
So what are you saying here? That
So if you define, let's say you take, X amount of arguments, and then you could take your arguments as a list,
yeah.
and then hand each one, call an init method for each of them. And so then you would overload init for each of the types that you have, assuming that you have different types for your arguments.
So you're saying that's how the programmer has implemented it, that if it gets an init with multi-arguments, it goes and calls init for each argument?
Yeah.
So,
So that way then
that's, you can reflect on yourself and see what argument types you have. And for each argument value, you can then call init with that argument
I
type.
think you define that initialization method in each type of the item, the object in the list. You don't call the init method in the array list, right? You need to
call init after you do the empty constructor and then call init.
because
Yeah. I think that's generally what I'm saying we should do. Unfortunately, there's no way in Java to make sure that a method is called only once in its lifetime, in an object's lifetime. But that's what you really want. So
You just check to see if there was some if method had been some Boolean flag.
So you have to implement that yourself. Yeah, the programmer has to implement it. Yeah, but it would be nice if we could say once. So, okay. So in general, physical state is larger than exported state, though that's not necessarily true. You could have one integer, and you could have gets for each bit of it, and have a different getter for each, and have to so the logical state will be larger. So with logical structure, you can have semantic equivalence, right? Because you can go into array list to vector and so forth. So you can do something like this, which is, you can say, for this serialized class, please deserialize using this class. Okay, that's possible with logic. That's what I require you to do in your homework. Okay, so deserialize array vector as array list. So let's look at component headers. Do we send component names or not? So for BMI spreadsheet, do we send height and weight? And or we go and send. So we just send the values, okay? Or do we send also things? So it works for unnamed components, of course. So for instance, for array list, you don't have to send the component names, okay? So when the order of names fields is fixed somehow, or no, same language, same compiler, or alphabetical sorting. And when you're doing full deserialization, because if some components are missing, then it becomes a little tricky. Okay, so some assumptions are needed if you do this. Okay, otherwise you go and send both the name and value of the component. Okay, that's what I would do. So you send height 1.77, weight 1.7, or you can go in, yeah.
What was the thing about the compiler?
So, if you're assuming that, you're not assuming alphabetical sorting. You're assuming, say, offsets. That this field will be stored after this field.
Okay.
Then you can use that order at the other end also.
Yeah.
That's what I'm saying.
So just like, what does that have to do with the compiler? Like just, if you have a structure or something, you want to...
No. So you want to know what the orders are, right?
Mm-hmm.
So the compiler always given an object with the variables, the compiler decides in what order those variables are laid out. It goes and has offsets from the beginning of the structure. So if you're using the offset sorting, okay, you can use alphabetical and you can use other things like what is the name of the superclass. But if you're just using that, then it helps. And a lot of these initial systems assume that.
So the offset is you mean the offset in the stream, the object stream?
Yes, if the offset in the stream is going to be consistent with the offset in memory representation.
That's a question.
You could. I'm just saying you could just, and who knows, So by the way, if you go and call reflection, it'll give you same object, different times, it'll give you different orders, the fields in different order. If you use introspection, it'll give you the properties in different order at different times. So this is what happens, so I create user interfaces based on what order I get these methods in and what order I get various fields in, and my UI keeps changing based on when we run it. Okay? So I'm not sure what's going on exactly there. Certainly the methods are given in different order without my recompiling the code. I never do reflection on fields. So if you're going to follow what the compiler did, the compiler is going to have a fixed, it's going to have well-defined semantics. There's going to be offset 0, offset 15, offset 20, offset 5. Then we need to, then we can do better. So, supporting heterogeneous platforms where you don't have to make the assumptions. And then you have this duplicated problem, can have components with multiple names, and, in that case you would have to go, and unless you go and assume this certain order of the superclasses, it creates problems. Okay. And then, how does the fact that you have polymorphic type create a problem? Yeah, because supposing I have an array list declared to be of type, or array of declared to be of type T, I can't assume every element is of type T. And then you have these big arrays, and you're going to send for each component the value. Okay, so that's why there are these attributes, annotations you can put in C#. You can say, I guarantee you that these values are all of this particular class.
At that point, why wouldn't you just type that?
As that class. It's just saying that I, as a programmer, am guaranteeing you. I'm using this type.
So like if I'm
And also, with generics in Java, it's all object underneath. Even though you may have declared it to be of type set. So here you're telling it that at runtime, and if we can extract that from the, you can imagine this annotation being extracted from the generic elaboration. But so I'm just saying polymorphism leads to more space overhead. Okay.
But then, like you suggest that in your lectures, that you could compress to refer to the previous types of arguments.
Yes. But compressing still means that I still have to have a reference.
Yeah.
Otherwise, I can just send the type once without even sending a reference also.
Yeah, if they're all the same.
Yeah. Okay, and these serialization systems have, because when does space get an issue? When you're sending big lists. Okay. So I'm just saying I don't know what I'm saying here. We just go recursively into it. And then this is where I talk about pointers, that you can have pointers within a message, and you can also have pointers from one message to another message. Supposing I serialize one object at one time, then I serialize another object another time. Can you imagine the second object serialization referring to the first object serialization? I think I talk about that.
Yeah.
And did you guys get it when it will work and when it won't work?
You do it in the right order.
So I send object off once, then I send object B, C, and then I send object O again. I could conceivably just have pointers to the original object, right? Or the object could have changed.
The object could have changed.
Because you could have changed the object after sending it the first time.
Oh, I thought you meant you were just sending this list of objects, and so then that would just, yeah.
No.
So if you send the thing, and then you do stuff, and then send some other stuff, and then sending that same object again.
So I can make Java break actually, because Java will do compression.
It'll even if you change the.
It doesn't know that.
So it's not checking the object's hash?
No,
It
it's
seems like
not.
That should be tied into the pointer.
That's my lectures seem to
Know
imply
it's
that
an object.
the last time I tried it doesn't do that, but it does provide you with a reset method, which I mentioned, and that reset method didn't work for me, which should go and reset the cache it has. So, yeah, I tried so many efficient ways to do serialization using Java thing, and I kept breaking it again and again. So I ultimately went to something inefficient. Okay, so you can point to the previously visited value, and you can point to the previously visited type. And so here we have repeated types, and it's I'm just telling you that it's used in all kinds of. Okay. And then this is what I'm talking about: independent serializations. You can have intermessage, or you can have intra-message.
Range that you.
So I'm sending, I can go and send the type ref the second time and say, by the way, the type I sent earlier is the same type I'm sending right now. Okay, so with types it's going to be okay. Types are not going to change. With values it becomes more of a problem.
Are you
So in that reference,
Well,
how would you reference a previous? Like, what would that reference be to the previous?
You could say the message number 1, message number 0. It is 0.0. The 0th message, 0th type in the 0th message.
So that should be an end, because it's an index.
It's like yeah.
Okay.
So that's what I'm saying here, right? This is a type ref.
Yeah.
The 0th first message I sent, the very first type I sent is the same type as this. And they do it. I mean, Java does a lot of complex.
So there are two messages, or?
Yeah, 2 messages. I went and serialized one object. I've got a stream open. I send one object. Then I think about things, and I send another object afterwards. So they're not related by some parent object.
Okay.
I'm sending a stack first, then I'm sending a queue later.
Okay. But what if?
Wait, so
Go ahead.
I was going to say the dot. I guess I'm confused.
And dot is just saying that when I have a reference within the same message, I just need one identifier. saying which component within this message should I refer to.
So that's more like a comma? So it's saying
Yeah, comma. Sorry, this I didn't realize this is like a decimal value. I'm using it like package names.
Okay.
Okay. So what if you send a very large object, it won't be divided into several messages?
Yeah, only one message, and then you do compression within the message, of course.
Okay.
Within the message, you always should do compression.
So no matter how large the
Then you know type names. You don't go and mention string again and again and again. You just say string is number 0. In fact, for strings and other predefined types, you can just send some well-defined numbers.
And so for ours, do we have to worry about compression?
No, not this kind of compression. No. You guys get your visited notes right. I'm happy. And then I'm saying here that you can have global addressing also, I suppose, that you can just order all the components by some global number. Okay, so this is just giving you some concrete.
Like where's this type graph stored? I mean, for this global addressing.
So the other end is storing it, is creating it, it's just storing all the references.
Okay.
Then you can purge the cache at some point.
Yeah, so it's gzip, basically.
Sorry?
The same thought as what is it, gzip?
Is that what it does?
So
Yeah.
What's the zip where it reads it into some period in history? It can reference itself, its prior send.
Same idea.
Okay.
In fact, all this stuff goes on a lot of time. You send images, you send all that stuff, This row of pixels is the same as this row of pixels, This is all colored red. Just send it once, These ideas you see again and again and again. There should be some course on compression. So inter-message compression reduces generality and correctness of serialization schemes, especially if you're sending references to object values, because those values can change. And like I said, I broke the code by changing the object. Okay, this is where I got the biggest headaches in life, when I was trying to do serialization. So, I can send. What if I'm sending the same object to multiple places? Okay, so I'm sending it to this site and this site. Why serialize multiple times, right? Just serialize once and send it across. And I tried my very best to do it. And I couldn't make Java work very well with that. Okay, and I think I made it work, and I'm a little scared. I keep forgetting because I kept trying various things. But a more general concept is that will not work if I have multicast other than broadcast. Because multicast means I send to one site. Multicast means a subset of broadcast. Just a subset of all groups. All users gets a particular message. So you see that if different sites are getting different messages, then I can't serialize them. I can't use these references, same references in both cases. Okay. The message orders are different. So what is it? So inter-message compression becomes an issue. Okay, so that's assuming we have a single serializer. Okay, and like I said, I got the stream corrupted thing many times when I tried to do this. Okay, but with broadcast it's better. Okay, then we talk about extensibility. So how do we do extensibility? We realize that we have to do extensibility. What's the algorithm? And these are some of the reasons why you might want extensibility. Some parts of the object cannot be serialized, so you go in at least automatically, or if you want to disable, so extensibility could also include declaring something as transient. That's extensibility, right? So you declare something as transient. Some parts of the objects need to be derived from other values. May want a more efficient scheme, and new patterns emerge. We need new serializers. If we are going to serialize an object into another kind of object, we need to go and provide some way of telling the system about how to map. Okay, so lots of reasons. shown here, said that typically what's going to happen is that I'm going to say if it's atomic, go to handle atomic. So I'm going to go and determine which components I'm going to serialize, in what order I'm going to serialize, I'm going to identify what the components are, and then I'm going to go for each component or descendant, we don't know, it's up to you. Go and say, hey, generic visit, now you go ahead and dispatch. Okay. So now the question is, how do we bind an object to a serializer? How is it done in Java? From what you remember of externalizable and serializable.
You inherit serializable, and then you can define that by the
So what?
methods that.
So you need to be able to access, you can go and take a BMI. Supposing you've got a BMI spreadsheet and a distributed BMI spreadsheet, and this class, you'll have to go and either extend these guys, in which case I guess you don't have to have source code, right? You can just extend it. But then what happens? If I extend a BMI spreadsheet, then a distributed BMI spreadsheet is no longer extending from me. So the extension idea doesn't really work. You have to go and change the class. Because that's what I'm trying to say here. Right? If I have this hierarchy and I don't have the source code, I can subclass this guy and make it serializable, but then I can't use that class in the serializable version of this guy. Okay. Okay, that's what I'm saying. Now I don't have an is-a relationship between these two guys. Okay, so we can't do this if we assume that we are extending. So we really have to replace that, put the methods in that class. So cannot have different serializable, different contexts, text versus binary, logical versus physical, mobile versus desktop. Okay. So what we can instead have is a registry with external custom serializer, and that's what Gypsy does. And then there's a special pattern for initializing serialized method, for initializing serialized object. Okay, and that's just a detail. Okay, so this is the kind of API that you guys are dealing with. We say for integer.class register this serializer, for this register this serializer, and so forth. Okay, you can say register serializer for a particular type, or register serializer for a particular pattern, like list serializer for bean pattern, collection serializer for list pattern. So that's the sort of flexibility you get.
And that's just an eval.
Just a constant, actually. It's just a string constant. Okay, so that I can define new patterns later without changing the type. Okay. Okay. So by the way, just to see, you guys are fresh with this, but you're also probably a little tired. You want to take the quiz today or tomorrow or Thursday? I'll put this on the web.
Do we have time to finish it?
The quiz?
Yeah.
Today you'll have to do it sort of after class. I don't know. We are about the end.
Finish up
Probably
the
will
slides
next time.
and do Thursday.
Okay, Thursday? You won't have forgotten all this stuff?
I might have forgotten it.
I will put this stuff, on the web. Look through the PDFs at least. The reason I wanted to do this is so that it's fresh in your memory, so that you don't have to study for the, study again. Okay, so that's good. That's good. We can do it on Thursday. Okay, so I'll take some more time then. I'll just to explain this. So what about buffering? Does the serializer have to depend? So does it matter whether you're doing synchronous sends or asynchronous sends when you're serializing? What are you doing in serializing? You're taking an object, converting it into a byte sequence.
Yeah. Well, if you're doing it asynchronously and the object changes, then what do you do?
Okay, so that is another asynchronous. No, we are saying that when it, we assume it's asynchronous to the following extent, that we don't wait for the object to be received, received at the other end, or to be, for other things to happen. But we may block till the object is serialized. You're right. If we don't block till that point also, if the object changes, you're in real trouble.
Do you think stay in the same order?
Who knows what's going to happen, right? So I think the serialized routine is always going to be executed in the same thread. You just have to do that. Okay, so when I say some operation is synchronous or asynchronous, I'm saying after it's been serialized. Otherwise, we don't even know what we're serializing.
I just mean like if you're going to refer to the types and things that you sent before.
Okay.
And you don't want like one of your asynchronous sends to be sent like in
different order.
Yeah.
That's good. So asynchronous could mean we're assuming in order. It just means that there's no, So the serialization is done, the compression you won't do. That's good. You won't do compression, inter-message compression, if the order is going to be. Usually you use datagrams when the data are like sending pointers, sending mouse pointers, and when they're not very important data. And usually that has its own kind of network level compression. There's sometimes byte level compression that's done. But you're right. If you're doing inter-message compression, that will be an issue. That's good. I should add that someday. But what about asynchronous versus synchronous sends? Which means in one case, after serialization, the guy blocks till the operation is finishes at the other end. And the other case, after serialization, it doesn't block. So I'm going to allocate a buffer for the bytes.
So you're worried about like a partial read happening, or?
No, I'm just worried about allocation of the buffer. Yeah, that I've allocated a buffer for the object, right? Do I allocate a new buffer each time? Each time I'm asked to serialize an object, do I allocate a new buffer?
Well, you can't write over the old one if you're hasn't been something.
So if it's synchronous, I know that I can overwrite because it's been used. If it's asynchronous, I can't overwrite.
But you can also
Do a copy. Do buffer.
No, buffer copy, creating a new buffer. What's the big difference?
But also, I think it kind of depends on what you mean by asynchronous, because maybe you processed and then things got sent over the network, and then you don't have to store the buffer unless.
Yeah, but the serializer comes. I'm assuming serializer is a separate. It doesn't know what's happening underneath. It just says, I'll take my object, convert that into these bytes, and then send it to the byte sender.
Mm-hmm.
It doesn't know when the byte sender is done. Which is a problem you guys faced in your in your NIO implementation, right? You just go and give it to the selection thread, and who knows when it's going to get around to sending it. Now you've got two threads. And unless they cooperate very much, which they do in my system, that after it's reused, I get a little notification saying it's been reused, it's been sent. Then I free up the buffer. Then I go and reuse the buffer. Okay? So what I have is a buffer pool.
I thought it was the serializers would feature their own buffer.
Right, the serializers have buffer, so what you do, so there's a buffer pool, and buffers get used when serialization happens. And when the NIO thread goes and tells me that it's been reused, it goes and sends me a notification. When I go in, at that point I go and return it to the free pool.
So there's a buffer pool of the receiver. Do you start off with like one buffer, and then when you need another, you allocate, and then you just don't deallocate? You start off with like 6 buffers.
Actually, what I do is and this becomes an interesting issue because that determines the number of outstanding sends I can have. Right? How big the buffer pool is.
Okay, so you fix it in and you say no more. These haven't been read. You can't send any more.
Or you get an error message. You get a message. So there's a little routine that I provide you with saying how big the pool should be. So when I'm sending when I go and send these commands in a loop, I broke my system because it would only take 10. The default was 10 because I don't want to go and allocate these lot of buffers in the beginning. Okay, I fixed the buffer pool size. Maybe I could have done better and grown it. But then if I'm growing it, what's the point of what's the meaning of a buffer pool?
Shrink it when you kind of dynamically
Yeah, I could have done
change
something.
with your input.
I could just increase its size. But and I think I tell you when you do your NIO implementation, you write your loop. I think I set the value too high, but please go and I'll tell you if I haven't told you. Use this particular piece of code that says set buffer pool size to this much. If you really want 1,000 messages to go across at one time. So yeah. Okay. So
What happens if it's full? Would you just block?
I just give an error message.
So you don't synchronize on
No, I didn't do anything more complicated. I should have.
This whole back end.
But the whole thing is to not block. That's the whole point. This is, you want asynchronous.
So die.
Asynchronous programming.
Yeah.
I don't know what I do. I might block also, but something bad happens. Either way, something bad happens. Oh, you mean block till the buffer gets released?
Yeah.
No, I didn't do that. Okay. So, but I give a big message. Just increase your size.
Because then you can see how many people are blocking and then sort of
Yeah.
change the number available.
Yeah, I have to think a little bit about this. Maybe I'll break something if I do that. But it seems not too hard a thing. But I just don't have a way to block a person. I mean, I could block. Okay. But I believe I don't do it. I might have done it. I don't know. I just know something bad happens. Okay, that you should increase the buffer pool size. Haven't you seen in sockets? It says, sorry, I've run out of sockets. Your programs can't run. So I'm not being very different from what the industry does. If you open too many tabs in Chrome, it'll go and say, sorry, I can't find a socket.
I've never seen that.
Oh, it happens to me all the time. Okay.
Aren't there something like 65,000 of those reports?
No.
How many sockets? Yeah, there's not a maximum number of sockets, is there?
Oh, there is. I have to reboot all the time.
Because the SARS.
Maybe that's when I'm debugging my programs and I don't close sockets. Maybe. Okay.
Yeah, that can happen.
But I don't know. But I know I have. I mean, just sockets sockets is different from ports.
Yeah, I was thinking
But
about ports.
it's
Sockets means a file table entry has been allocated. The file table entries are not very big because that's in the kernel space.
I think you have a lot of the file handlers, but it's not a small number.
I think you can make them arbitrary.
I run into them all the time. Sorry, cannot find a socket.
Maybe it's a configuration thing. 'Cause
Yeah.
I'm pretty sure you
Maybe
It's
can.
my Windows. Windows 8.1. And sockets should get closed when my processes die.
Yeah.
So, but I run into this all the time. You can go into, we'll Google afterwards and see how many sockets can you.
On Windows?
Yeah.
Maybe just have a fork phone.
You mean an infinite fork? No, I don't know. I'm pretty sure.
That's something you would help them
The sockets is per process.
explode.
It's per process.
Mm-hmm.
It's just that they don't want,
Okay.
you know.
Maybe have a thread phone.
Yeah, no. I'm pretty sure this happens in regular. I think it happens even when I'm not. Sockets is a scarce resource.
I
Okay.
think there's a default limit there.
Yeah, because it's a file table entry.
But I mean, you can set a larger value for
Okay, so you can go and set. This is my point. Even if you can, I'm not sure you can, because then the programmer can go and make the kernel go and allocate a whole lot of space for it. Even if you can, that's the same principle as what I use, where I say you can set a default number for the buffer pools. The same principle. Okay, I'm not saying two wrongs make one right, but I'm kind of saying that. Okay, what about at the other end, receiving end? Can I use the same byte buffer for multiple receives? So I've got the object, I convert that into, I've got a byte buffer, I convert that into an object, can I reuse the byte buffer for the next object I receive?
Yeah.
He's already copied the information.
You already copied the information. So these are all issues you have to deal with, when you're doing serializers. Okay, so
Is there a red square in the pool?
sorry.
Is there a red square in the pool?
This is part of that we are sending a serializer pool rather than serializer. So what I did was I had serializers pooled together, and each serializer was bound to a particular buffer. Okay, that's how it sort of worked out for me. So there is some routine that goes and says, take my object and convert that into a byte buffer, and it gets an object of type pool rather than an object of type serializer. Okay, and each serializer uses only one buffer. That's rather than one serializer doing multiple. So you guys don't have to worry about pools. You just assume there's one buffer. Or do you? I forget. I think you're given the buffer. So I give you the buffer into which you should serialize. So you don't have to worry about the pool. That's why I did it, I think. And I'll just combine your serializers into pools to make that all happen. Okay? Okay, this is something I do. That if I can't serialize it, for some reason, deserialize it for some reason, I don't have the class, something bad happened, I just give the receiver the byte buffer as the object. And it can do whatever it wants to with it. It can forward it, it can relay it, it can do anything it wants with it. Okay? So I won't go and give a message called stream corrupted thing. I mean, I actually use Java serializer underneath. But if for some reason I can't, I don't have the class, I'll just give you the buffer. And that helps with the relayer. Relayer is an example where, in Java, in RMI, your relayer had to have the class of the object. It had to understand the command processor. Well, in your case, you're just sending strings. But in general, in RMI, you have to have the classes of the objects that are sent to you if you're a relayer. In my system, you don't have to have the classes. You just get the byte buffer, you relay it across, and that's it. Okay, so then we talk about weakly typed languages, and the type of the variable is ambiguous. So programmers disambiguate based on the application-specific knowledge in a program. But what happens with the serializer? So give up on C, and the standard solution is to use an IDL. Okay, in this case. And then it's a real pain because you've got to have a type def in C, and in C you have to have C.h file and IDL file. Whenever you change the C file, you've got to change the IDL file. Nobody wanted to use it. And what I did was I just said, okay, you can go and put a little annotation saying, this is really this type. And you basically take an existing type and annotate it rather than have a whole new type system into which you translate. Okay? And IDL is also useful in supporting multiple languages. Okay. And then the question is, if languages are OO, does IDL for serialization have to be OO also? And you can just have a little structure if you want to. You don't have to have the whole type hierarchy. That it can just take the value, it can store it, or it can forward it without even interpreting it. So that's the point I was making at the beginning of the class. That even though I don't have the class of the object, I can just store it or forward it and don't have the class, okay, which I think is a very big benefit. Okay. And what to do with handling of, to do with unknown types, can invoke, supposing you do have the class, supposing you do get the class, your program was not prepared to have that class, you just got the class suddenly. So what do? Well, you can sort of invoke a method or super type that you know. So that's what happens in applets. In applets, you just get an object, you're going to do the start method on it. You know that's how you're going to interact with it. So whatever object you get, you call the start method on it, and an object-specific method gets called. Okay? So you can do interesting things even though you didn't have the type when you were writing the program. Okay. One of my sort of examples was that I'm a client and you're a server, you don't know anything about me. I don't want to do the processing in the client itself, so I send you an object and then I start calling methods of that. So you're now serving me, even though you didn't know anything about me. Okay. Got all kinds of security problems, but assuming that's okay. And this is sort of telling you how this all works together in Gypsy. That you go and call, you send an object to a particular port. That guy sends it to some forwarder, which goes and sends it to the serializer, which goes and sends it, creates a byte buffer thing and sends it to the next level. So you really don't have to know this, but just to let you know that there's a whole pipeline into which you fit in, is the point. Okay, so when you go and register your serializer, you'll just say, hey factory, call my serializer, and that something in Gypsy will go and put that serializer in the pipeline. Okay.
What does the send forwarder do?
So what I do is, the send forwarder does nothing. It's something that can be replaced by another object that does some interesting things. So I've got this pipeline in which each component is replaceable. So I can replace a serializer, and I can also go in, before I serialize the object, I can put a little filter here. That's my own filter, rather than a system-defined filter. So this is a very complex piece of code which is going and, saying I'm going to allow you to send objects on a port. Okay, so it deals with a lot of things, but you can write a little code that says whatever object you're serializing, before you serialize the object, I'm going to massage it somehow. I'm going to timestamp it. I'm going to do something interesting. And at the other end, you can also then untimestamp it. Okay, so it's just for extensibility. But you don't have to worry about it because you're changing this component and not this component. You might change this component in another assignment. I forget in the fault tolerance whether you need to do it or not. Okay, but I'm just showing you there's a pipeline here. Okay, and here's the other last issue, and then we're done. When you're sending typed data, when you do your fault tolerant assignment, you'll be using a session port, which means you'll be sending a message to a group of people in one shot, rather than sending it to each one individually. So I'm doing the relay somewhere inside my code does the relaying. So the group communication is built on top of, the multicast is built on top of unicast. Okay, and we have group byte communication and group object communication. So the question is, do I go from group type data to unicast type data to byte communication, or do I go from group type data to group byte communication directly? Okay. And this seems more modular, right? And this seems less modular. But you guys see what's happening here?
Every time you have to serialize.
You have to serialize each time. Okay? Serialization done once. Okay, so that's what we do in Gypsy. Okay, this just shows you how this serialization works with marshalling. So we have byte communication, object communication, remote procedure call, and object reference communication comes on top of this because you may be sending you're sending remote values that on which you can invoke methods later. So basically, sending a reference value in a serialization means you're assuming there's a method invocation capability there. Okay? So that's how the layering is going.